All right, well, welcome. I'll start off with the space news here, covering roughly a month.
The Chinese launched 3 astronauts, or taikonauts as they call them, to their space station. They're going to be there for 6 months, and during that period, they're going to be adding a couple of new modules. So if you're looking at a picture of the space station here, as shown, what you're seeing is the core module in the center. You're seeing on the left and right-hand sides, you're seeing a cargo spacecraft that were previously delivered. The crew came up on the crewed spacecraft, which is kind of dangling down from the bottom here, facing Earth. Now, where they're going to be adding the new modules is in that junction between the left spacecraft and the core module. There's 2 more docking ports there, and they will be adding to those. You will end up with a kind of a T shape when all is said and done. Now, there's other features visible here. For instance, they have a robot arm over here on the right side of the core module. It's kind of like the Canadian arm on the International Space Station. The additional 2 modules that will be added will each have their own robot arm as well. The whole thing with these cargo spacecraft right now is about 120 feet long, diameter is maybe 14 feet. They're not ready for it yet, but the Chinese have said that they are interested in having international partners join them at some point. I don't know how hard they're looking right now, but they're certainly expecting maybe some Russians and maybe some others could join them up there. In other news, the Boeing Starliner unmanned test has finally been completed. Now, if you recall, this goes back quite a number of years when NASA decided they needed to have an alternative to launching astronauts to the International Space Station only on the Soyuz craft. They wanted to have something that wasn't Russian. So they set up a commercial program, and they ended up awarding a contract to 2 companies, Boeing and SpaceX. And the idea was that they would compete with each other, and both of them would end up with the capability of getting astronauts up to the space station. SpaceX succeeded with this fairly early and has been launching on a fairly regular basis already. Starliner from Boeing fell behind, and they've had a variety of problems over the years. But finally, they managed to get their unmanned test done. The next step then would be delivering actual astronauts. So NASA has officially declared them to have passed the test. They did, in fact, have some problems. What happened was on the approach, they had some maneuvering thrusters that failed. These are fairly large thrusters. It turned out that was okay. They have enough of them with redundancy built in. The thing worked anyway. So 2 smaller thrusters used during the docking procedure also had failed. But again, the redundancy kicked in. We'll probably never know the exact causes for those maneuvering thruster failures. We don't really know. Those were in the service module, which is a disposable part of the overall craft. So we might never actually know that. I haven't heard anything more about the causes of this. There were also some minor glitches in the cooling system for the thing, and also during the docking. The first attempt didn't actually succeed, but these were relatively minor glitches that were addressed by actions of the crew on the ISS. So the Starliner launched on an Atlas V rocket, spent 5 days up tied into the space station, docked there. Astronauts in the space station could go in and explore it and make sure it looked all right. And then they completed the test coming back at White Sands, New Mexico, 5 days later. Moving on to an update on the James Webb Space Telescope. Good news is that the full-color images are still on schedule to be revealed on July 12th, and I'm sure they'll have some fairly spectacular images. There was a little bit of bad news about the telescope. One of the 18 hexagonal mirrors was hit by a micrometeorite. Now, this was about the size of a grain of sand, but that is bigger than really could even be tested for in the labs before. The problem being is that things move really, really fast. They had tested us what would happen if particles even smaller than that, more dust particles, happen to hit things, and they've been hit 4 times previously. And they do expect gradual degradation as a result of that. When the grain of sand hit, it did actually have an impact on it. They've made adjustments to the mirrors. These mirrors can be completely adjusted at a very, very accurate scale. They found they could only partly compensate for the effect of distortion. But the good news is that the telescope still performs better than the mission requirements. There has been a lot of activity lately regarding spacesuits, both for the space station and for the Artemis moon landing program. First, the moon. A NASA auditing group had discovered that the spacesuits that were in development would not be ready for the original landing date for the first Artemis moon landing, which would be Artemis 3 in 2024. It turns out that they said the earliest they possibly could be available was 2025, and probably would be later than that. So they raised a red flag and said, okay, this could impact the entire program. So there are no moon spacesuits as of yet. The problem with the ISS spacesuits is they exist, but they're over 40 years old. Not in design, but their actual suits themselves are at least all 40 years old, and some older than that. Of those, only 18 are even usable. So these suits are not in the freshest conditions. Now, they've had problems with them in the past, in particular, the problem of while you're out on a spacewalk, having water build up in your helmet. A pretty scary thing. So they had originally, some time ago, had done some kind of a fix for that. They've been watching it very carefully, but it turns out that lately the problems come back, and people are getting water building up in their helmet while on spacewalks again. So right now, all spacesuit use around the International Space Station has been halted, pending the outcome of an investigation of, why is all this water in the helmets. So, two separate spacesuit problems. NASA has decided to contract a little differently to get these spacesuits made, and they're going to spend optionally up to $3.5 billion through 2034. And the way they're doing this is they're doing it kind of like the way they did the Commercial Crew program. They're setting up two independent contractors, companies that bid on essentially renting these spacesuits to them. And they want two, so there's competition. And so there's two competing teams, like Commercial Crew. One is Collins Aerospace. They have an advantage that they've been building spacesuits before and have been working on them. Axiom Space is the other one that got the second contract. They're also a pretty good choice because they, in fact, were developing spacesuits anyway. They're developing a space station, and they have their own separate program going for making spacesuits. Now, it turns out that the requirements are really somewhat different for the space station and the moon because of gravity. When you're on the moon, you need to be able to walk around, so you need good flexibility at the joints for walking. You need to be able to get back up if you fall down. There is gravity. There's also a lot of dust. None of those things are true at the space station where there's no gravity. You really don't even need to use your legs very much. So whatever happens in the lower part of the spacesuit was never really very important. So both of these companies are going to have a modular sort of a system where there's some core parts to the spacesuit, mainly the parts that are going to be touching your skin and providing cooling and so on. And then they'll have separate special packages for for dealing with either the moon or the space station spacewalks. That was not specified in the contract. This is NASA kind of backing off and saying, we don't want to influence, how you creatively come up with a solution for these problems. Just give us the spacesuits and we'll set certain requirements. Those requirements include things like being able to fit everybody between the 5th and 95th percentile on size. That had been a problem before, where there weren't enough spacesuits that were small or large for the spacewalks on the space station. So the business model here, just to emphasize that, it is renting, not buying. And think of it as very much like renting a very expensive tuxedos. They could be rented out to anyone. It doesn't have to be NASA. It could be, a foreign government or a private company. That's opposed to essentially selling things, which are really kind of the equivalent of small ships. You think the ultimate small ship is a spacesuit. So these spacesuits do have to be available for 2025, which would be in time for the Artemis 3 moon landing. Now, independently from all this, SpaceX has been developing a spacesuit just for spacewalks, or not for moon use. So that's kind of independent of this particular program. Our next topic is an interesting demo by Nanoracks.
General goal is they want to be able to do construction in space. And that includes disassembling stuff in space. So for instance, if you want to get some metal, this long range picture, you want to get some metal, you go out and cut up an old upper stage rocket or something, turn it into a habitat, whatever you need to do, cutting and welding and so on. So the very first step here is just doing cutting, and which doesn't sound like it's a big deal, but it actually kind of was, because for one thing, in normal cutting, imagine you have a circular saw or something. You're shooting out all kinds of pieces of metal, basically, shooting off. Not a good thing in space. That little grain of sand, damaged the the James Webb Space Telescope, same problem. Anything going 17,000 miles an hour in a slightly different direction than you're going, and you've got trouble when you get hit by that. So that matters a lot more. So they came up with a technique that's basically milling, just meaning, normally milling is rubbing, but what they do is they just go to really, really high speed. And somehow they figured out that they can do this, that basically just melts the metal as they cut through it without sending off sparks. Now that was a theory, and apparently it worked on the ground, but the question is, would it work in space? And they're testing it. They had 3 different coupons, different metals. The main one of interest was 316 stainless steel, which apparently is what the Vulcan Centaur rocket is using. Not that different than SpaceX, I guess, when you get down to it. The whole thing was about a 10-minute demo, because what they do is they have a robot arm with a milling end attached to it, built by a company called Maxar. They run the thing for 10 minutes, do the cutting, and then the thing is it's attached to the upper stage of the Falcon 9, which after an hour, they give them 1 hour. After the 1 hour is up, they're going to deorbit the thing and then it'll burn up. So they had that time to do the experiment and then also transmit a video. So essentially the result of the experiment is present the video, and then put some nice words around the video. So anyway, the goal, though, as I said, is they have a whole program for advancing space manufacturing. This will involve assembly as well as building and cutting. So what happened? Well, they did launch Transporter 5. This was the most recent of the SpaceX missions, which is a lot of small satellites all packaged all together. They went up in this last month, and they did the test. And they tweeted out saying, "This is great, we're up here, we're going to do the test now." And they haven't said anything since. So probably didn't go completely as planned, is my guess. But we would have heard by now. It's been a couple of weeks. So I'm still hoping that maybe something came out of it. Yeah, that was the official mission pass. I think that, the little coupons they were cutting might have looked pretty much like that as well. The Lucy asteroid mission, we talked about this back when it launched back in October last year. This is the one that's going on a mission over the next 12 years. It's going to really 3 sets of asteroids. There's the Trojan so-called Trojan asteroids, which are the ones that are trapped around the Lagrange points in front of and behind Jupiter. They are places where gravity is stable enough that things tend to accumulate. And so there's asteroids that have accumulated there in those 2 spots, plus a few others. This mission sends this probe called Lucy out to visit them over a 12-year period. It's a really long period because to do all the visits they want, they actually make 3 flybys of Earth as a part of the process. Each time, they're coming by Earth, and Earth pulls it a little bit and gives it a little bit of a gravity boost. So that's how they're getting by with very little fuel. Now this is interesting because it has solar cells. Usually the deep space probes like this typically have some kind of nuclear heating source, and rather than solar cells. They went with solar cells, and you can see them here. To be able to fit into the fairing and nose cone of a rocket, they have to be all folded up. So they're on these long poles, which probably are folded inside the rocket. They open out, and then they unfurl like a fan. They unfurl the solar cells, and they found on both sides. And there's 2 sides. So the one on one side, pretty much, that's probably almost closed. It actually finished as a latching for that curse at the very end, and they go, "Phew, we're done." One of them didn't quite finish. It didn't quite latch. And they've known this for a while. They've been working on all kinds of simulations and analysis, trying to figure out what's wrong. And they concluded that somehow or other there was just too much slack. They have a motor that essentially you can imagine pulls cables, which tend to pull these things around. And somehow or other it got too loose and it got wrapped around a motor or something. So that they're not, of course they can't see it, but that's not really a hypothesis. What they've tried several times, and during May in particular, what they did was they have the normal motor that does this unfurling, and they have a backup motor. And so they tried running both of them in parallel to get more force, and hoping nothing would break in the process of doing that. And they said they managed to get it a lot closer to being latched, but not quite. Now, what they think, though, is that even if they don't manage to get it to latch, just keeping the tension on the cables that are there is probably good enough. They say they're getting, I forget if it was 80 or 90%. They're getting most of the solar power they need anyway. And that's mainly only a problem when you're out as far as Jupiter. I forget the exact numbers. When we did this talk about the original launch back in October, it was something like 1/10,000th of the light is available out there as opposed to here, but that was still enough. There's a lot of power right now, but when they're out of Jupiter, that's when they really need everything. Okay, miscellaneous items. Blue Origin did another suborbital flight, 10-minute ride up and back down. And then kind of a fun one here, NASA is commissioning a small study to review unidentified aerial phenomena. They've changed the name from UFO. It's a more general title. It probably makes sense because it might be a phenomenon, not necessarily an object. It's going to be a 9-month study. And what they're going to do is they're going to issue an unclassified report at the end. Now, the purpose of the study isn't really to go and definitively say this was a UFO and this wasn't. What they're going to do is first they're going to identify where is all just the source of data, because it's in a lot of different places. Figure out how to collect the data in a more organized way going forward, and then figure out just how to use it and how to make real decisions. So you're not going to see a report one way or the other in this 9 months saying, aha, there's no such thing, or there is such a thing. They're simply going to say, here's a way to have an organized program. And they're going to spend up to $100,000. So that tells you right there, it's not too expensive a program. A few people. Okay, launches. How many launches have there been since the last meeting, which is around May 14th? How many? Well, that's better than your million guess from last time. You're closing in. Well, you're a lot closer. I have to give you that. Any other guesses? You're getting really close now. Okay, how many think there were more than 11? Okay, well, sorry, no, actually it's only 10. You know, of course you have the usual SpaceX putting up Starlink satellites. You know, you're always going to get some of those. That service, to really make money, they have to have their newer, bigger satellites up there, which won't fit in a Falcon 9. So they really need Starship to do that. So they've already kind of said they're not really going to be really good until everything else falls in place. We already talked about the Boeing Starliner, and that went up like that. The Russians launched a military spy satellite. The Falcon, the Transporter 5 mission we mentioned already. This is a typical thing where SpaceX just accumulates a whole bunch of all small satellite jobs, sends them all up. Now, there's trade-offs on this, and we've actually talked about this before. You know, they're going to take you to one orbit, which is typically a polar sort of orbit. And a lot of little satellites, well, maybe all those satellites don't all want to go to exactly the same orbit. So the way they do that is there's 3 separate companies that have little space tugs built in there. And what they do is they spin out, and then each one of those in turn can move around and deliver satellites to different orbits. And that's kind of how the economics are shaping out. It's still a lot cheaper for companies to do that than to launch on a smaller rocket. You know, it does mean that there's a lot more dependencies on, you know, having exactly this kind of ride. Rideshares in general, that's the name for taking a small satellite on a big satellite launch, has caused a lot of scheduling problems recently. Every time a big satellite gets postponed, which happens all the time for various reasons, all the little ones who are going to tag along all of a sudden have to reschedule. You know, if it's just a low Earth orbit kind of a thing, it doesn't really make much difference. They can easily absorb that. But sometimes the missions were for long range, like the Psyche mission, which is the one that's going to look at this giant metallic asteroid and potentially do some prospecting there. That got postponed until September. Well, there were some rideshares that were going to go along with that. They were going to go out and look at some other asteroids. Now they've got to reschedule those. An interesting one, Doug, you'll like this because you thought it was funny last time. So a Chinese car maker is launching satellites. The reason they're doing it is something to do with autonomous driving. They want to be able to use it for distributing software and so on, it's just their network. And the other thing is for navigation as well, instead of GPS. The Russians launched a cargo ship at SpaceStation. I already mentioned the astronauts going up. Then the last one here is just an Egyptian telecom satellite, which sounds pretty routine, and it is. But what's interesting is this was the first commercial launch to geo kind of an orbit. Normally, in the old days, the bread and butter for rocket launch companies was sending big satellites up to geosynchronous orbit, doing things like broadcasting TV or whatever it is they're doing. There's not as much of that anymore. Most of the activity these days is low Earth orbit, kind of things like Starlink and OneWeb and so on. So this far into the year to even get to that kind of a launch. Now, there have been others. I mean, there have been military launches and that sort of thing for spy satellites. Okay, any other comments or questions? It's pretty clear the main space powers of the US and China. I think what will happen is the Russian program is really kind of falling by the wayside here. You're going to see mainly military satellites or still supporting the space station. That cargo ship, they are still supporting the space station. You know, they actually are keeping their agreements that they will continue doing.
There was a question about why we're not seeing more from the small launchers, such as Rocket Lab in particular.
I thought there would be more of that. Rocket Lab in particular is the one you'd really expect. And they're held up to some extent by procedural kinds of issues. I mean, they have their Wallops Island facility, which hasn't really been fully blessed by the government yet, so that can't quite take off. Some of the missions actually weren't quite ready yet. But, you know, when you get down to it, the economics still favor SpaceX with these transporter kind of missions. Putting up a lot of stuff at once is just cheaper per kilogram than the smaller ones. What their big advantage is, if you're a small launcher, is going right to the orbit you want. And the problem is all these little companies that are making the Sherpa and all these space tugs. they're actually kind of cutting into that business. I mentioned there were three. I should have said something more about that. One of those was from a company called Momentous, which has had all kinds of financial problems, and even people questioning whether they're really a real thing. They have an exotic propulsion system based on microwaving water as a propellant, a little different, a variation on an ion engine. One of the companies, they actually broke off, SpaceX broke off their contract with them. So they're no longer going to deal with them. They'll finish out the missions, but they're not going to do any more. Okay. All right. So I think time to move on to the featured speaker. Okay. So Chris, actually, his background was more turbo machinery and that kind of thing. He's a professor also in doing consulting, doing both things. Got involved in starting new ventures in places like India. Went to school in Germany in mechanical and aeronautical engineering. And he's going to talk about the Hunch program, which is where high school students get to design stuff that actually gets used by NASA, mainly in the space station. So.